Let's look at this question on the board. The question is 4 raised to the power of x plus 2 raised to the power of x plus 1, all divided by 2 raised to the power of x gives 16. Find the value of x. How do we approach this question? If you know how to solve this, pause the video and solve, then drop your answer in the comment section before resuming the video. Okay, let's look at it together. In this question on the board, at the left hand side, which is this, numbers are being divided by another number. That means there's a fraction in the left hand side where we have numerator and denominator. But in the right hand side, we have just 16. Now, this is how to approach this fraction at the left hand side. In the left hand side, which is everything that we have here, we also observe that this numerator, 4 raised to the power of x plus 2 raised to the power of x plus 1, are sharing the same denominator. So we have to apply the law called division distribution rule to this. That is the first thing we have to obtain. The division distribution rule, because they are sharing the same denominator. Now, if we have solution first, since we have 4 raised to the power of x plus 2 raised to the power of x plus 1, all divided by 2 raised to the power of x equal to 16. Now, applying the division distribution rules to this, it will become 4 raised to the power of x all divided by 2 raised to the power of x plus 2 raised to the power of x plus 1 all divided by 2 raised to the power of x. That's how the division distribution rules works. Because they were sharing the same denominator, 2 raised to the power of x, when distributed among the single terms in the numerator, we obtain this. So this is equal to 16. From here, we have 4 raised to the power of x divided by 2 raised to the power of x. Now this is very simple because they are sharing the same power, x and x. Because they are sharing the same power, we can go ahead to divide 4 by 2. So that becomes 4 divided by 2 gives 2 raised to the power of x. Don't forget to put power x after the division. But over here, we can't do the same. Reason is because they are not sharing the same power. The numerator has its power as x plus 1, while the denominator has its power as just x alone. We cannot do that. The only thing we can do here is to apply the division law of indices. Division law says that if A is raised to the power of x divided by A raised to the power of y, the result becomes, because A and A is occurring here and they are the bigger number called the base, then it will become A raised to the power of x minus y. The law states that when two quantities are being divided, the law states that when two quantities of equal bases are being divided, their index is being subtracted from each other. So that means we subtract this from this. Numerator, the index of the numerator minus the index of the denominator. Index is the same thing as power. Take note. Let's bring this knowledge over to here. So in this term, we are having 2 as the base and 2 as the base. Applying this division rule, that becomes 2 plus 2 raised to the power of the base of the numerator minus the base of the denominator. And the base of the numerator is x plus 1. So we have over here x plus 1. While the base of the denominator is just x. So that becomes minus x. Minus x equal to 16. Equal to 16. If you understand to this point, comment "I understand the first stage of the calculation" on the comment section. Let's proceed. 2 raised to the power of x plus 2 raised to the power of x plus 1 minus x is equal to 16. That gives 2 raised to the power of x plus, over here is 2, then x minus x is 0. That means we are only left with 1 as the power of 2. So let's put the 1 here, and this is equal to 16. 2 raised to the power of x plus 2 raised to the power of 1. 2 raised to the power of 1 gives 2. 2 raised to the power of x plus 2 raised to the power of 1 is 2, equal to 16. What did you notice in this stage? We observe that this 2 has a power, and the power is a letter, not a number. Why this 2 is a single number without a letter being attached to it? The same with 16. No letter attached to it. So they are called constant terms. We are going to transfer these 2 to join 16, family of constants. So that will yield 2 raised to the power of x is equal to 16. When plus 2 moves to the right, it changes from plus 2 to minus 2. Then 2 raised to the power of x is equal to, observation from the question that was given, it was equal to 6 and it was never 16. So this expression is equal to 6 and not 16. Equal to 6, equal to 6, So we have 6 minus 2, and 6 minus 2 is equal to 4. At this point, the left hand side of the equation is written in their power form or index form, that is 2 raised to the power of x, while the right hand side is not written in its index form. To get the final solution to this, we have to compare the left to the right by making the 4, which is in the right hand side, to also be in its index form or written in their power form. So that gives 2 raised to the power of x is equal to put this in their power form, it means 2 raised to the power of 2. Because 2 raised to the power of 2 gives 4. By the method of comparison, since the two bases are the same, therefore their respective powers must be the same. Or you can say, let this cancels this, and x is equal to 2. Therefore, x is equal to 2.